electrocautery is a common technique used in all surgeries. And it is a technique that uses large amounts of electrical current to cut tissue or coagulate vasculature, so to stop blood flow. In monopolar electrocautery, as you can see in the image, the current flows from the generator to the tooltip, where it burns in the body, and then the current dissipates through the body until reaching the ground pad and returning to the generator. You can see that there are two different modes of electrocautery in this video. So first, there is the cut mode, and then you will see the coagulation mode, which is used to coagulate blood vessels. There's a very high complication rate of monopolar electrocautery in laparoscopic surgery. So of 200 patients that go in for a laparoscopic surgery that they use actual monopolar electrocautery in, one of these patients is going to leave with some type of unnecessary injury that resulted due to an accident. So we want to find a way of minimizing the complication rate. Due to the camera and the television screen, the surgeon only has a limited view of the surgical field. So we want to try to provide some kind of feedback so that the surgeon actually knows what's happening off-screen. So our objective was to enable surgeons to know when they are cauterizing tissue. This means that the tool tip is in contact with tissue, that current is actually conducting through the tissue to burn it, and that they are actually burning tissue. So we want to provide this feedback using vibro-tactile feedback in order to inform surgeons when they are burning tissue. And we believe that vibro-tactile feedback is a better option than audio feedback or visual feedback because we're replacing the tactile cues that are being lost due to the nature of the laparoscopic tool with another form of tactile cues. We believe this has potential to improve the safety of laparoscopic monopolar electrocautery by providing an intuitive way to the surgeon to know when they're actually cauterizing tissue.
Throughout the entirety of the demo, the surgeon is constantly activating the cautery, but note that the actuator on the tool handle only vibrates when the tool actually comes in contact with the tissue, despite that the cautery is constantly being activated.
We conducted a user study using a range of individuals ranging in experience from fourth-year medical students all the way through experienced surgeons. They were asked to complete a basic electrocautery simulation, and then were asked to fill out an evaluative survey to give us some feedback on our device. Of the 5 subjects that we surveyed, all 5 liked the vibro-tactile feedback component that our device gave. None of the 5 subjects felt that the additional feedback given by the device impaired their use of the electrocautery tool, and 4 out of the 5 subjects noted that they felt that the feedback improved their use of the tool.